Here's pre-calc number 1-36. It says Megan went walking for 2 hours and walked at a steady pace of 3 miles per hour. How far did she walk? So if she walked for 2 hours at 3 miles per hour, the way I did it is I just thought of each hour is 3 miles. So 3 miles plus another 3 miles is 6 miles. That's just how I thought of it. And then letter B says to make a careful graph of the situation with the horizontal axis having units of hours and the vertical axis having units of miles. Oh, units of miles per hour. Shade the area under the curve. You should get a rectangle for the area under the curve. The area under a curve means the area between the curve and the x-axis. So we talked a little bit about different kinds of units that we can put in on the axis. We're used to seeing time usually on the x-axis, and a lot of times we see distance on the y-axis, but in this particular problem we want speed or velocity, or we want the miles per hour on this y-axis. So that's 1 mile per hour, 2 miles per hour, 3 miles per hour. And then, sorry, this isn't in the middle. This is 1 hour, 2 hours. It looks like it's off to the right. I didn't do a nice job, and I'm in pen. So when I first wanted to draw my graph, I was thinking about the problem that we did in class about the car that got on the freeway for a while, and that's what I first drew. And then I looked at the answer key, and they had a different answer. So I think because it says that she's doing a steady pace, she walked at a steady pace of 3 miles per hour. And because walking, I think you could start walking like immediately at 3 miles per hour. Like you're at a stop, and then all of a sudden you go instantly to a 3 mile per hour walking. So I don't think it's like a car where it takes a little while to accelerate up to speed. I think you could actually just start walking. Like think of a treadmill, like when you just push the button and you could just start walking right away. And then I guess you could just stop. You don't have to slow down before you stop when you're walking fast. So that's why this just having this steady rate like this all the way across, like every bit of the time, like this would be a half hour and that would be a half hour. Every bit of the time that the person was walking, they were going at a steady pace of 3 miles per hour. So that's why it's straight like this. And they went for 2 hours. So that's 1 hour and that's 2 hours. The reason I drew this line down is because it told me to shade the area under the curve. I didn't really shade it. I could shade it. There. Now it says, on letter C, it says divide my rectangle into 6 smaller rectangles by drawing vertical lines at the 1 hour and 2 hour marks. So this is my 1 hour mark, which is skewed off to the side for no apparent reason except for that I didn't judge my space very well. And then here's my vertical line at 2 hours. And then it says draw horizontal lines at the 1 mile per hour and 2 mile per hour mark. So if this is 1, this is 2, this is 3, I need a horizontal line at the 1 mile per hour mark and at the 2 mile per hour mark. And I see that that gives me 1, 2, 3, 4, 5, 6 rectangles that should be all the same size. I wish it was a computer and I could just pull my line over and it would be more even. So we've done what they asked in letter C. Now letter D says explain why each of the smaller rectangles, these 6 rectangles, explain why each of them that I created in part C represents a distance of 1 mile that Megan walked. Hey, that she did walk 6 why did I say that? 6 miles. She did walk 6 miles. 1, 2, 3, 4, 5, 6, right? That's how far she walked. But why? What are the units of the sides of the rectangle? That's my hint. Like, why do each one of these rectangles represent 1 mile? Giving you some think time. Well, if this is kind of like an area model. You know how length times width is area? Like hours times miles per hour equals area. So what I could do, I don't know if you realize this, but miles per hour can be written like this. And I can do fraction math, or we call it dimensional analysis. Ta-da! So this is just an introduction to a calculus concept that has to do with area under a curve. And so I hope that made sense.